All right, so we're going to look at the derivatives of trig functions. So these are functions that the derivative you're going to just need to memorize, and I can run through some examples real quick, and then I kind of want to prove why they are the way they are. So the derivative of sine of x is actually going to be cosine of x, and the derivative of cosine is going to be negative sine of x. The derivative for tangent is going to be secant squared of x. So I have some limit definitions here, right? We got the limit as h goes to 0 of fx plus h minus f of x all over h as that limit definition of a derivative. And then I have those special trig limits here, right? They might come in handy. So I'm going to show you how we can find the derivative of sine of x with that limit definition, and then I'll do the same for cosine. And then I might show you how to get tangent of x with the quotient rule. I think that'll be just something fun to do. So, all right, we have the limit as h goes to 0 for sine of x plus h minus sine of x all over h. Now, I might need some other trig identity knowledge, so I'm going to put an additional thing here to give those. So we probably need to know what sine of x plus h is. So that is sine of x cosine of h plus cosine of x sine of h. And we'll probably, for the next one, need a cosine of x plus h. So I'll go ahead and give that here as well. So that's going to be cosine of x cosine of h minus sine of x sine of h. All right. So I can do that substitution, right? So I have the limit as h goes to 0 of sine of x cosine of h plus cosine x sine of h minus sine of x all over h. All right, I'm going to group some things together. Instead of rewriting it, I'm going to look at these two things here and take out a GCF. So the limit as h goes to 0, I'm going to pull out sine of x. So I'm left with cosine of h minus 1, and then plus cosine of h sine of h all over h. Notice that this right here, cosine of h minus 1 over h, is that special trig limit for sine, or cosine, sorry. So that's going to go to 0. And I should really break that up. So I have the limit as h goes to 0 of now 0 plus the limit as h goes to 0 of cosine of x sine of h all over h. I'm out of colors here. This is the other trig limit, right? So it's going to be 0 plus that goes to 1, so that's going to leave me with the limit as h goes to 0 of cosine of x, which is just going to be cosine of x. Kind of cool. All right, so let's do the same thing for cosine. And I'm going to break it in half so that I can do the tangent of x as well. Okay, so we have the limit as h goes to 0 of cosine of x plus h minus cosine of x all over h. Do that substitution, cosine of x plus h is actually cosine of x cosine of h minus sine of x sine of h minus cosine of x all over h. I'm going to do something very similar and group these together to pull out a GCF of cosine. So I'm left with cosine of h minus 1 minus sine of x sine of h all over h. And now I have those two trig limits, right? I've got this one and this one. So if I were to break it up and say, all right, the limit as h goes to 0 of cosine of x times cosine of h minus 1 all over h minus the limit as h goes to 0 for negative sine of x sine of h all over h. Go back and do this in green. This one goes to 0. So I'm left with 0. And then this one goes to 1. And I have the negative here twice. So I'm left with sine of x. And 0 minus sine of x is negative sine of x. Okay. Now I could do the limit definition with this tangent function here, but I want to do quotient rule. Because, right, I could rewrite tangent as sine of x over cosine of x, right? So if I do the derivative of tangent x, which would be the same as doing the derivative of sine of x over cosine x, we can do low d high minus high d low all over low low. So I even said low and it wasn't right. So low, and then d high minus high times d low all over low low. I can do some simplifying. So that's going to be cosine squared plus sine squared all over cosine squared. And then I could do my identity here. Cosine squared plus sine squared is actually just 1. So 1 over cosine squared. And we can do another identity to get that to be secant squared, right? So it's kind of cool. So if I just do some basic examples here, I didn't have any prepared here, so I'm going to do them off the top of my head. But let's do something like 2 cosine of x. Well, the derivative, I guess I should say, find the derivative of each. So, all right, 2, and then derivative of cosine is negative sine. So the derivative is negative 2 sine of x. Could do another one and say, let's do, I don't know, 4/3 sine of x. So, all right, 4/3, and then the derivative of sine is cosine. So these are pretty basic. We'll get into chain rule, then that'll be a little bit more interesting. All right, so something else to talk about here is higher order derivatives. So we've been doing the first derivative. We can keep going. We could do another derivative or another one. So we've got the first derivative, and here's some notation here. Or we've got the second derivative, also have some notation here. Got the third, right? And then once we start getting into larger numbers, we just go ahead and put the numbers. You know, if we wanted to take the 100th derivative, we're not going to want to put 100 tally marks or figure out what the Roman numeral is. We could just put 100, all right? So let's find these derivatives. So this says find the second derivative. So to find the second, I need to find the first. So I get 9/2 x squared plus 10x minus 6. And then I can find the second. So I'll multiply that by 2. The 2's will cancel, so 9x and plus 10. let's do the fifth derivative, and we'll see something interesting that happens here. So, all right, let's find the first. So negative 12x cubed plus 21x squared minus 10. And then we'll do the second. So negative 36x squared plus 42x. We'll do a third. So negative 72x plus 42. Do a fourth. Negative 72. And all right, I'll do a fifth. 0. So something interesting happened here. So if I have a derivative that is higher than my highest degree, then it's going to go to 0 because I have nothing left to take. Remember, derivative takes 1 from the power each time with this power rule. So like here, this third degree, if I was taking 2 derivatives, I'm left with 1. So that's a fun fact here. And what about these trig ones? Because they might flip-flop, right? So I'm going to do something interesting. So instead of doing 32 derivatives, or like in part D, 867 derivatives, I'm going to do a little trick. Because I think there's going to be a pattern here. So the first derivative is cosine. The second derivative is negative sine. The third derivative is negative cosine. And then the fourth derivative is back to sine, right? So we have something interesting going on, because then the cycle is just going to repeat, okay? All right. So notice, it repeats every 4. So since we have 32 times, we are going to see how many groups of 4 I can get, right? So that's going to give me 8 groups of 4. So I would go through this 8 times. 4, 8, 12, 16, so on and so forth, until I get to 32, and I'll end here. So the 32nd derivative is just going to be itself. Let's do one for an odd one, right? So let's do the first derivative, and that's negative sine of x. I'll do a second derivative, and that's going to give me negative cosine of x. A third one will give sine of x, and a fourth one, and I'm using f, and I should be using y since it gave me as y of x, is going to give me cosine. So now we're same like 4 as the pattern, right? So if I take 867 and divide it by 4, 867 divided by 4, I get 216.75. So I get 216 rounds of this, but then I have 0.75, which is 3/4. So I have 3 left over. 1, 2, 3. So the 867th derivative of cosine is sine of x. So if we had, I don't know, let's just say we had 220.5. So this just worked out nicely, that 7/500 reduces to 3/4, and it works out here. But this 0.5, 5/10 or 1/2, if we want it in terms of 4, that's 2/4, so it'd go 1, 2, and we'd be at negative cosine, right? So however many you have left over, or if we do the long division, divided by 4, so it was 216, which leaves 864. So leaving you with a remainder of 3. You can find the remainder to find out how many more you'd have to go. All right. Potato launcher fires a potato downward from the top of a 112-foot tall building. The potato hits the ground in 2 seconds. Find the initial velocity of the potato. The position function is given by this function here, where the distance s of t is in feet and time t is in seconds. Okay, so we know the potato hits the ground in 2 seconds. So s of 2 is 0. So let's plug that in. So negative 16, and then 2 squared plus that initial velocity times t plus 112. So 4, and 16 times 4. It's going to be negative 64 plus, and I'll just put the 2 up front, plus 112. And we know that equals 0. So I get 48 plus 2 times that initial velocity. And let's see, I'll subtract 48 and divide by 2. So that initial velocity is going to be negative 24 feet per second. All right, that's all I have for this section. So if you have any questions, let me know.